Okay. You may want your calculators for this, by the way, so go ahead and get those out. Section 2.6, perimeter and area of similar figures. We know what perimeter is. We know what area is. We've done a lot of area this year. In fact, we started off the year with surface area as one of the first topics that we talked about. Surface area, of course, is the two-dimensional area on a 3D shape. Area is just, well, it's just the area of a it's just a two-dimensional thing. So I guess they're both area, but we're not going to be talking about three-dimensional solids today. So perimeter. When two figures are similar, the ratio of their perimeters is equal to the ratio of their corresponding side lengths. Say that again. When two figures are similar, the ratio of their perimeters is equal to the ratio of their corresponding side lengths. So these are side length ratios. Side AB corresponds with the blue triangle to side DE. Side BC on the red triangle corresponds to EF. And so replace those with numbers. Maybe it's 3/5, 3/5, and 3/5, because we know the ratios are always the same on two similar figures. What I'm saying is if the side length ratio is 3/5, the perimeter ratio is also going to be 3/5. When you label perimeter, how do you label it? If my shape is measured in meters, how do I label the perimeter? Carson? Just in meters, exactly. I don't do meters squared or meters cubed. I just do meters. So it's in the same dimension. Length on a shape and the perimeter of a shape, they're both one dimensional because they're both just lengths. So I don't do anything special with my ratio. It's the exact same. Find the ratios, red to blue, of the perimeters of the similar rectangles. So let's see. Let's start with the side length ratios. What's the side length of the width of the red rectangle? Jacoby? What's the side length of the red rectangle? What's the side length of the blue rectangle? 6. Jacoby, what's the fraction 4/6 reduced to? I was gonna say, I think I heard you say it. So the side length ratio of width to width is 2 to 3, or 2/3. So when it says what's the perimeter ratio, well, since the perimeter ratio is equal to the side length ratio, the perimeter ratio is also 2/3. So I'm done. The height of figure A is 9 feet. The height of figure B is 15 feet. It's similar. So I know that the ratios should be proportional. What is the ratio of the perimeter A to perimeter B? So let's start with the heights again. Just like we started with the widths of these rectangles, let's look at the heights. Carter, what's the height of figure A? Okay. And what's the height of figure B?
15.
15 feet. And Carter, what would 9/15 reduce to? Because I should always try to reduce my ratios.
Wow. Does it reduce?
It does. Yes. There's a number that goes in a 9 that also goes in a 15.
3.
Yes.
So it'd be 3/5.
3/5. Okay. So my side length ratio, by the way, the side, even though the height may not be a side length of a triangle, it's still considered a length. So we can call it side length. If the side length ratio is 3/5, the perimeter ratio is also going to be 3/5. In a moment, we'll talk about how we can actually use this, because right now you might be thinking, so what? What do I do with that? Well, it's going to help me find missing values if I can set up a proportion. Before we do that, though, let's move on to area. So that's perimeter. Now we got area. When two figures are similar, the ratio of the areas is equal to the square of the ratios of their corresponding side lengths. So if, again, to use that same ratio of 3/5 that I used in the last example, If the side length ratio is 3/5, the perimeter ratio is 3/5. But if the side length ratio is 3/5, the area ratio will be 3 squared, which is, let me try it again, 3 squared, which is 9, over 5 squared, which is 25. Okay, similar to how we looked at just a moment ago in our last section. If the side lengths are being changed by ×3, the area was being changed by 9 times, right? And so we're squaring it because it's area instead of just perimeter. So the area ratio is going to be equal to the side length ratio squared. Let's write the side length ratio of these two triangles. Garrett, what's the side length of the red triangle? What's the side length of the blue triangle? Okay. As always, we should reduce. So Garrett, what is 6/10 reduced to? Okay. I guess we just did this one. I was unaware that I was going to be using the same numbers again. I'm sure they're fine. That was a loud rumble there.
Sounds like something gross.
So when you square a fraction, by the way, you are squaring the numerator and the denominator of that fraction. And here's why. And you probably already knew that, but if you didn't, if I'm squaring a fraction, squaring means you're timesing a number by itself. So you're doing 3/5 times 3/5. And remember, when you multiply fractions, you multiply the numerators and the denominators. It's not adding fractions where you find a common denominator. You actually multiply both levels. And so that's why you could just say, I'm going to square the 3 to get 9. And I'm going to square the 5 to get 25. So the side length ratio is 3/5. The perimeter ratio is 3/5. But the area ratio is 9/25. Okay, let's do another one. The side length ratio is 8/7. That means the perimeter ratio is 8/7. It's going to bother me that I didn't use the same color purple. It's also bothering me that I can't erase it. Perfect. So the side length ratio is 8/7. The perimeter ratio is going to be equal to that, 8/7, but the area ratio, now I can't reduce 8/7, so I'm ready to go ahead and square it. What is 8 squared, Sky? And what is 7 squared? 49. So the area ratio is going to be 64/49. By the way, if you didn't reduce, well, your answer would be wrong if you didn't reduce. But if you didn't reduce at the beginning, you could still reduce at the end. So I'm going to go back up one example. If I wouldn't have reduced 6/10 before I squared it, I would have gotten an answer of 36/100. But I would have had to have reduced that. 36/100, if you reduce by 4, gives you 9/25. So you get the same answer, but it's a lot easier to reduce 6/10 than it is to reduce 36/100. Okay, so I mean, reduce early, then you won't have to do it at the end. So it's not like it ruins your answer. You can still get there. It just causes you to reduce more. Here we didn't have any reducing to do, so we're ready to go ahead and square. Why is one set of side lengths enough? For example, on these triangles, did you notice they didn't give me all 3 sides? They only gave me 1. So why is one set of side lengths enough? Because the figures are similar. All the corresponding side lengths are going to be proportional. Meaning I only have to use one side length ratio. I don't need to use all of them. On these two triangles, if I use the corresponding side lengths 10 and 12, or sorry, not 10 and 12, 10 and 15, that's going to reduce to 2 over 3. If I use the corresponding side lengths of the bases, 12 over 18, 12 over 18 is also going to reduce to 2 over 3. So the point I'm trying to make is you only need one of the side lengths. You don't need all of them, because the fact that they're similar triangles or similar rectangles or similar shapes means that any of the corresponding side lengths, they're all going to give you the same reduced ratio anyway. What you can't do is what some of you guys were doing on the 2.5 homework. When you're creating your proportion, you cannot do 10 to 12, 15 to 18. Because even though those are proportional, they're not the side length ratios. The side length ratio would have to be 10 to 15 corresponding heights to the corresponding bases of 12 to 18. Okay. All right, let's look at a problem here with a swimming pool and a sand volleyball court. A swimming pool is similar in shape to a volleyball court, which means they're both rectangles, but more than that, they have proportional side lengths and equal corresponding angle measurements. Find the perimeter P and the area A of the pool. So here's what I know. I know the width of the pool is 18. I know the width of the volleyball court is 10. I know the area of the volleyball court is 200 yards squared, and I know the perimeter is 60 yards. That is enough information for me to find the area of the pool and the perimeter of the pool. It wants me to do both. So we'll start with perimeter. To find the perimeter of the pool, I'm going to need to know what the perimeter ratio is. To find the perimeter ratio, I'm going to need to know what the side length ratio is. So what are the side lengths of the pool and the court? I guess I'm looking at both the widths here. So we'll start with the width of the pool. What's the width of the pool? Carson? 18 yards. Okay, 18. What's the width of the volleyball court? Anybody? 10? Okay, so my perimeter ratio is going to be 18 over 10 because it's the same as my side length ratio, which is 18 to 10. Now, is that reduced? Let's reduce it. Okay. Seth, what is 18 over 10 reduced to? 9 over 5. Good. You don't have to match the colors up like I do. I just find it aesthetically pleasing if I do. So, okay. So my perimeter ratio, because it is equal to my side length ratio, I just got to find the side length ratio, reduce it, and that's my perimeter ratio. So it's 9/5. Now that I know what my perimeter ratio is, I can use my perimeter ratio to set up a proportion to find the perimeter of the pool. So here's my perimeter ratio: blue for pool, brown for volleyball court, sand, I think it's sand volleyball court. Okay. What is the perimeter of the pool? Well, we don't know. So we'll call that X. Or P for perimeter if we want to, that's fine. What is the perimeter of the volleyball court? Xander? 60. It's given to us. So then I can set up a proportion that says, here's my perimeter ratio. Here are my actual perimeters. We can cross multiply and find out what X is, or you know what? I like using P. Let's use P. P because it's the perimeter of the pool. And so we cross multiply just like we did in section 2.5, 5P. I know I didn't give you a whole lot of workspace there. I'm going to use the lowercase p. 9 times 60. Jace, what's 9 times 60?
500.
Okay, and can you divide that by 5 and you'll give me the perimeter of the pool.
Oh,
108. Now, how do I label perimeter, Jace? Just yards, exactly. 108 yards. Let's recap for a second. Find the side length ratio, reduce it, and then do nothing to it. and you'll have the perimeter ratio because the side length ratio is equal to the perimeter ratio. Use the perimeter ratio, 9/5, to set up a proportion using the perimeter of the pool and the volleyball court. Of course, we don't know the perimeter of the pool, so we use P for that variable. Cross multiply it, and you get 108 yards for the perimeter of the pool. Let's do the same thing for the area of the pool. Remember that the area ratio is equal to the square of the side length ratio. So we already know the side length ratio is 9/5. So what I need to do is I need to square 9/5 so that I'm using the right ratio. Max, what will I get when I square 9/5? 81/25. Excellent. So I'm using the same ratio, but the squared version of that ratio to do the area problem. So I'm going to write 81/25. That's my area ratio. And to set up my proportion, I'm going to use the area of the pool and the area of the volleyball court. Again, I don't know the area of the pool. Let's call it A for area. And then what's the area of the volleyball court? Carson? 200 yards squared. Good. So I'll put the 200 there. We cross multiply just as before, but I have a slightly different ratio because I had to square the ratio before I set up my proportion. So Martin, what do you get for 81 times 200?
16,000.
Okay. 16,200.
Yeah.
And then divide it by 81 and label it yards squared. I hesitate saying this, but there is actually a way that you could do this problem slightly faster. Also, you do the last one. Oh, is that the wrong answer?
No, yeah.
It's just 200. Wait. It can't be the same area. It can't be the same area that as the.
Oh, wait.
It-
It's 81.
You said 81 times 200 was 16,200.
16,200 divided by 81. 200. Divided by 25.
Go. Quit doing what I write and do what I mean. Yeah, it should be 25A, shouldn't it? Sorry about that, Martin. Is it 648? Okay, I just had it written wrong. Okay, you were right. Yeah, I wrote 681A instead of 25A. I'm working too fast in my head. Okay. So what I was going to say, which would have been a way of checking our answer, knowing that our answer is right, but the word's wrong, is when you look here, you can actually see that there's a factor of times 12 to go from 5 to 60, right? And so you could just say 9 times 12, and that gives you the 108. What are they timesing 25 by to get to 200? Carson? 8. So then 81 times 8 is all I really have to do, and that gives you 648. Now, I tell you that method, but that method doesn't always work because it doesn't always work out to where the bottom two numbers have a whole number scale factor like that. Sometimes it's a decimal, and then it's like, okay, I can't do that in my head. So cross multiplying works, and that's a pretty quick way of getting your answer anyways. All right, so I got some homework problems for us to look at. Number 15 and 16, number 17 and 19. They are assigned in tonight's homework, but I'm wanting to do them with you guys together. So we'll do them here on our notes, and you can copy it over to your work paper later. Number 15 says the ratio of the side lengths of square A to the side length of square B is 4 to 9. The side length of square A is 12 yards. What is the perimeter of square B? Okay. Start by writing the ratio of the side lengths to square A to square B, and you'll write 4/9. They give you that ratio. Oh, hold on a second. Okay, I need that. Okay. It says the side length of square A is 12 yards. So if I put an X right there, that'll give me the side length of square B. So what is the side length of square B? If I cross multiply that, Xander? 27. Okay. You can cross multiply that. You could also say that since 4 times 3 gives you 12, that 9 times 3 would give you 27. Okay. But it wants to know what the perimeter of square B is. And so the fact that this is a square tells us that all 4 sides are going to be equal to 27 on square B. And so what would that give you for the perimeter of square B? Yeah, Lizzie? 108 yards. Yeah, just times that by 4, because if you know one side of a square, you can find its perimeter.
Since it's 4x, you wouldn't have to divide it and then just multiply it again, just leave it at 4x equals x.
Oh, that's true. And then not divide it and just leave it at 108. You're right. Yeah, I didn't see that. Oh, well. Extra work for no reason. All right, number 16. The cost of this fabric is $1.31. What would you expect to pay for a similar piece of fabric that is 18 inches by 42 inches? So the key word here that you may have overlooked is similar. And so if it's similar, that means it's going to be the same exact, not just a rectangle, but the same exact kind of rectangle, just in this case larger, because it went from 9 inches by 21 inches to 18 inches by 42 inches. We don't actually need a ratio here. What is the scale factor? What are they timesing the side lengths by? Lizzie? 2. So if they're timesing the side lengths by 2, the area must be how many times bigger? Maddox? How much? 4. Yeah, because you have to square that, right? Take the side length ratio, square it, which I know I didn't really write a ratio here, but if you take the side, whatever they're timesing the side lengths by, square that, and that's what you're gonna have to times the area by. So if they paid $1.31 for that tiny piece of fabric, and this one's 4 times bigger, shouldn't they pay 4 times the price? So what's $1.31 times 4? Sky? $5.24. There you go. There's your work. That's an easy one to like just guess on and not really know how you did it. And that's why I wanted to go over that. Number 17 will be saved for tomorrow. Number 17 and 19 both, because I'm not going to have time to finish number 17 in the 80 seconds or so that we have left in class. And so I might even use a little bit of your success time tomorrow, since you guys are going to period 6 success time to answer this question.